Hey guys, welcome to Great Learning. Python is considered to be the best programming language in the world today. Now, there are numerous reasons as to why this is the case. One of these reasons is the fact that Python provides you with a ton of flexibility in terms of functions and their usage. This is a huge advantage as functions are used in 99% of all the programs written using the language. Now, considering that functions are a fundamental part of Python that you will use during your entire programming career, we here at Great Learning have come up with this video discussing about everything you need to know to get started with functions in Python. Make sure to watch till the end of the video to have a complete understanding of what functions are, how they work, and a lot more. On that note, are you guys excited to get started? Well, let's go.
Before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, coming to the agenda on this particular video of functions in Python, we will start this out by taking a look at what are functions, right? I mean, we need to understand it on a fundamental level, so we definitely have to check out what they are, how they're used, where they're used, and once you understand all of these, you'll be very curious to understand how would you go on to define your own function, maybe in Python, or in fact, it's very similar in the other programming languages as well, right? But in this particular case, we're going to be talking everything Python, as you've seen from the title of the video, right? Fantastic. After understanding how we define a function, we're going to be taking a look at the various types of functions that we have available in Python. Once you understand the various types, you will be very much excited to start a hands-on session, or you'll be very much curious to actually go on to start working with all of these functions, understand what they do, and know about their fantastic features that they provide as well, right? To make sure that you have a complete understanding there, we will make sure to take a look at all of these kinds of lists, be it string functions, list functions, nested functions, lambda functions, math functions, recursions, pure and Boolean functions, and of course there can be more as well, right? So we're going to discuss multiple examples in all of these functions to give you a complete understanding of the same. Well, fantastic. Now let's get started with what are functions, right? Now, when you actually go on to understand about functions, there is one really important bit that you have to understand. Functions have a primary purpose of being a reusable block of code, right? Now, when I say a reusable block of code, imagine using the print function, right? You see, print is a function and we use print in many different ways. In any way we want, we can go on to use print, right? So that's reusable. Everything that print is doing for us, right? It's taking in an output, it's trying to maybe merge a variable in there, take a look at the access specifiers, all of that. It will process everything and eventually it will give us a final result that we can go on to see, right? This final result is definitely what we're after, and that entire process of you just opening up print and typing in something and having an output is very simple, because print function is helping you out there, right? If it weren't for the print function, you would have to manually sit and try to code the functionality of how an input is processed, how the data is processed, and eventually how the output can be rendered onto the screen as well, right? It's a lot of things that go on in the back end, but the function in itself makes it super easy for us. So a function is a reusable block of code that can be used again any number of times as and when required, and it is used to perform a specific task. A print function will use to print an output, right? It's as simple as that. A print function cannot be used in a way where you would probably assign a variable to that, right? I mean, of course you can print variables, the values of the variable, the address of the variables, everything you can print, but you cannot say a equal to print, right? That will not work. That's an important thing you must understand here. Now, Functions are not the entire program, which I'm very sure you would have figured out by now, right? So functions are mostly one part of the program, even though as soon as you look at the piece of code, they look like tiny bits of elements with your parentheses, brackets everywhere. You might feel that, hey, this doesn't feel like it has a huge impact on my program. Well, try to implement the functionality without using the function, and then you will understand how much of a effort it is, right? We're going to be also seeing this practically as well. What happens when you don't use a function, and of course what happens when you do use a function, right? A lot of code just becomes one tiny line, like 5 or 6 characters, and you're done, right? I'm going to be showing you all of that as well. Now, in this way and in many other ways, functions are basically put into place so that it adds a convenience piece for us whenever we're going to work on a program, right? Think about this. You're writing a very long program, or you're solving a very complex problem. If you do not have some kind of help, it would definitely be difficult, right? Now, you could be a person who would say that, hey, I am a very good programmer. Do I require functions? You can be a fantastic programmer, but the talk here is that once you stop worrying about the how the things work in the backend, or would you have to manually implement a function on your own. All right, guys, now take a look at the last line. It says using functions will make your life very easy in terms of programming. I'll be very honest with you. Whenever we go on to discuss about this, people usually come up to say, hey, I am a fantastic programmer and I can write the functionality without even having the use of functions. And I don't think I would require functions, and I don't consider them as, the number one important thing. Well, let me tell you this. If we go on to actually use a function rather than not use a function, in terms of efficiency, in terms of you actually having to spend your time to actually write the code down, make it work, debug it, check the functionality of it, and do all of this, and eventually have the exact same thing as a ready-made function, which is again probably 10 times, 100 times easier to go on to learn to use, and eventually you can just keep repeating that, right? You don't have to have your block of code where you manually wrote the functionality for a function to help. That is where your life becomes easy. You will definitely get a lot of time to actually think about solving the problem, or in fact working on the logic of the problem rather than breaking your head about the syntax, right? Now let me tell you how the functions are the number one helpers, right? Of course, I gave you a quick overview of them, but when you're taking a look at the advantages of using it, first of all, it has to be code modularization, right? Now let's just say I have 10 lines of code, which is a functionality of how you can print something on Python, right? But when you're going to print something on Python, it's usually one line of code. Now if you were a programmer and you definitely had to, like, let's say print something 100 times, you have to do it manually. Would you rather have 1,000 lines of code, or maybe 100 lines of code, which is like the exact same thing, but you just change what it is that you want to print on the screen, right? I definitely think you guys will prefer the second one too. Everyone does. That is where breaking your code down into simple pieces, bite-sized pieces, is definitely the way to go. And then take a look at the second option. The second option says program organization, right? Now I call this as an option because even with using functions, you definitely can have cluttered programs, but there are some functions wherein as soon as you go about working with the functionality, you will definitely not give a thought about how it works, or eventually as a learner itself, right? As a beginner, you definitely want to get to the solution, and you also want to work towards understanding how you would get towards the solution, right? But if the program looks very complex, you don't understand anything, there's a lot of code, even though it's just a simple thing, the output is super simple, the program is complex, so you will be very confused as a beginner, right? This is where if you use functions, eventually you go on to tackle this particular problem, right? You will have fantastic program organization in a way where each of these functions, and if you understand what those functions do, it is a very powerful tool. And I definitely believe in this particular concept where if you know how to effectively use functions, that is the big jump from you being a good programmer to you being a fantastic programmer, right? That is something I wanted to tell you guys. And of course, increased manageability. When everything is structured and when everything is in a modular form, or when everything is in an organized fashion, don't you think that most of the things that we're about to discuss will be its advantages itself in many ways? Well, yes, of course, even with increased manageability, manageability as well, you as a beginner will be less overwhelmed, and of course you will understand what the code does. And Python is a programming language where your input code will be a lot less and your output will be a lot descriptive. Now when I say that, I don't mean that physically the length of the code will be less. The complexity that's involved in you solving the problem will be comparatively less, and eventually the output will showcase more of the solution in a way where it would portray that the problem would have been simple to solve at the start, right? That is also an important thing where functions play a lot. Right? Fantastic. Now the question arises saying, okay, so now we're talking about Python. How do I go on to define a function in Python, right? To define your own function in Python, there is a fantastic keyword. This keyword is called as the def keyword. Def stands for define, right? D-E-F. Now, this is a method which is, again, used if you are going to create a function on your own. This is where we will have to talk a little bit about the types of functions in Python, because you have user-defined functions and you have built-in functions as well, right? Here, first of all, we're going to quickly, go take a look at the user-defined function. And as you can see, the code block for a user-defined function is going to basically start with a colon, right? If you're wondering about, hey, is this only for the user-defined functions or does all the function work in the same way? Well, all the functions, the print function, in fact, if you're taking a look at, another programming language like C or C++, where it says printf, scanf, C in, C out, right? All those have a functionality that is written in the backend to do this. Similarly, here in Python, so basically here in Python as well, there is functionality, but then to get to that functionality, you have to define a function which provides the body for it, right? That is where you have the syntax that's shown on your screen. A function will always start with the def method, then the name of the function, and eventually it'll have a colon. And of course, below the colon, you will have some sort of indentation. Now, the indentation is very important. If you don't follow the indentation when you are creating your own function, eventually it's going to give you a simple error, and of course you will figure the error out in a second and you will fix it, but then understand that it's a flow, it's a logical flow of code that happens inside the function as well. So that's where indentation is super important. Now, to define your own function in Python, you're gonna have to understand two things here, right? One is actually defining the function, and the next thing is to call the function whenever it's required, right? Let me give you a simple example. Maybe if you're cooking in the kitchen, right? So let's just say tomorrow morning I have breakfast and I'm hosting a brunch for my friends, right? Not right now. This is a hypothetical situation. We're in COVID pandemic. Please stay safe, right, guys? Okay. So I'm having a hypothetical breakfast tomorrow morning, and I invite all of my friends. Now, to prepare for that breakfast, or if it's a very fancy food that might need marination or that might need a couple of hours to, for example, if I'm making pizza, the dough needs to rise, right? So I need to put it in the fridge the last night. Similarly, defining a function is a part where you're actually creating that pizza dough and you're letting it rest for a while and eventually putting it in the fridge, and you're coming the next day to use it, right? When you actually go on to use the pizza, that's when you're calling a function. If your pizza is the function, when you call it is exactly when you want to use it, right? If the pizza dough is sitting in the refrigerator, it is not a pizza. You cannot eat it just like that. So just defining a function will be of no use unless you actually make use of that function. Now, to make use of that function, we use this terminology called as calling the function. Calling the function is basically us saying, hey, whatever is defined under your functionality, please run everything, and I require the assistance of all that functionality right now. Let me give you a simple example here. Take a look at this. What you see in the first block of code, which says def first function, is basically, of course, a function definition, right? Here you'll see that the def keyword is used. The name of the function is first underscore function, and every function has to have parentheses, right? Parenthesis is basically the round braces. Once you have the round braces, there is a compulsory colon. Now, for every programmer who has ever started learning Python, and if we have any intermediate viewers watching this particular video, you will know that there is a very good chance you will miss that colon every single time, right? It happens. It happens even to the best of us when we are working on a very complex problem. And of course, Python will just give you a small error where you can just fix it instantly. But make sure while practicing from the start itself that you guys pay a lot of emphasis on the colon, right? And of course, the second line, look at the print line. It's indented to the right? So it belongs to the part of the function here. It's a very simple print message that says, hello, dear learners. Now, if you're wondering about print being a function, you'll be like, hey, where are the round braces? Well, look, there are round braces, and what I want to be printed on my screen is exactly the parameter I pass to the print function. It'll go to the back and it'll be like, hey, this is the message that we have got. We want to print this, so let's make sure we get this to the output. That is how Python thinks in the backend. But then just having this will not make sense in this particular case, because there it will define a function that will print something for us. It's almost like us creating the pizza dough and putting it in the refrigerator the previous night. Now tomorrow morning is when I would definitely want to pick it out, actually make the pizza and serve it, right? That is where a function call comes into the picture. Alright, so take a look at the function call that's been put on your screen, right? So all we have to do is very simply just call the name of the function and we are good, right? That is how simple it is to define your own function in Python. Now we're going to take a look at the various types of function in Python that we have. And I already spoke to you a little bit about user-defined functions. Again, we have another entirely different video where you can completely learn all of the in-depth functions in terms of the built-in functions that we have and how you'd go on to use it, and even everything about the data types and the data structures as well. We have multiple videos on the channel, so make sure you guys check this out. Anyway, coming back to built-in functions, right? So there's many built-in functions in Python. At this moment of time, during the time of this creation, I'll repeat that. At the moment of time, during the creation of this particular video, there is somewhere around 68 built-in functions in Python. I am sure you might have already used these functions, right? The functions are integer, print function, list function, sum function. All of these are some of the things that Python provides to you from its package in itself, right? You don't have to install anything. Now, there's a very good chance you might have not used the int function though. You might have used print, list, sum. There's a ton of functions out there that make life so easy for us, right? Of course. And coming to the user-defined functions aspect of things, on how you would go on to create your own function, that is exactly what we just took a look at, right? You're going to be using the def function. All the functions, built-in function, user-defined function, any function in Python will have the def keyword associated with it, right? Of course, there are certain exceptions, but then those are the real complex concepts that you might get confused if I start talking about right now. Anyway, all of these things, be it user-defined functions, be it built-in functions, it is super important for all of you all to take a look at understanding all of these practically, right? That is the reason in this particular video, we're going to have a demo where we're going to be taking a look at multiple functions, right? Now, when you're working on strings, there's multiple functions that will help you with that. When you're working on lists, again, there's multiple functions for that. Similarly, you can have a function inside another function, and there's so much math operations that you can do, and a ton of other things as well, right? So here are some of the 8 different types of functions that we're going to take a look at. Of course, all of these functions belong to their own niche categories where they are put to use at its best, right? Fantastic. Now, let me quickly open up a Google Colab and we can get started with it, right? So Google Colab is basically a simple Jupyter notebook that is hosted on the Google Cloud platform. Fantastic. Let me open it and we can get started. Alright guys, so we've just opened up Google Colab here. As you can see, it's an interface very similar to the Jupyter Notebook, right? I love working with Google Colab, and most of the time I use this because of the sheer amount of convenience you get, just like how you would if you were using functions in Python, right? Anyway, I have multiple things planned here, as you guys can see, and all of these are cells and all of these are functions that we're going to discuss, right? First of all, we're going to start this out by understanding on how you guys will be writing your first function. We'll take another look at understanding another simple function. So after this, we're going to take a look at understanding something called as the scope and the lifetimes of variables, and eventually we'll take a look at all of the functions, right? Fantastic guys. Now definitely this Jupyter notebook can be shared with all of you all. You can also use this, but then I highly suggest that you all implement all of this manually yourself, rather than having a ready Jupyter notebook for reference, right? That way you will have a chance to learn the concept better if you're trying to implement the functions on your own. Anyway, let's get started, right? So this is your first function that we actually spoke about. So whenever you guys are writing your first function, so as you guys can see, the first word is of course the def word, right? It has to be the defined word where we're talking about the function. Now, what's the function name? It's first underscore function, and we're the functionality that we're providing inside is print, right? Now let me go on to execute this as it is. I'll click on the play button here, and as you can see, nothing happened, right? Nothing happened because we have just defined the function and we haven't called the function here. Now let me go on to actually call the function, and here you will see that, hey, we have a message that got printed, right? So all the backend that was involved when you just put in this print function here, you really don't have to worry about, right? It's Python's headache to make sure that it works for you. But can you also see that there is a small indentation here, right? Now what happens if I actually go on to remove the indentation? Of course, it auto indents for me because it understands that. As soon as I run this, it will give me an error. It'll say expected an indented block. Now let me indent this and run again. That way it should work fine. Don't miss the colon, don't miss the indentation, and of course when you've defined a function, make sure you guys are calling your function to make sure it works, right? Fantastic. Now what I'm going to actually do is take a look at another example, another simple example of how you guys will go on to work with a function, but this time we are taking in a parameter where we are actually interacting with Python here, right? So again, this is define another function. The function name is called as greet underscore function, but here we'll be taking an input from the user and basically use it to put out an output as well, right? Now as soon as I go on to run this, I ran it, nothing happened. Why? Because this was defining the function and not calling the function, and I just have to print in the function name. Right now here I have something called as name here, so this function is expecting an input from my side as a parameter, right? So if I just call greet function without with just empty braces, it's not going to make sense, because I'm not passing any values where values are required, so it's going to go out to be an error, right? But then now that we have a name here, and this is basically my name, right? For all of you who didn't know, my name is Anirudh Rao, guys. So it just says, hey Anirudh Rao, good afternoon. Now this is a simple print function again, but then here we just took in a parameter as well, right? So this was another simple function. Now we're going to come to a part where we're going to be understanding the scope and the variable lifetime, right? Now this is a fantastic concept. Let me just walk you through the function. First, we have a function called as ani underscore function. Of course, it has to be ani. And then we have a equal to 5. A is basically a variable with an integer value. And then it says the value inside the function is dash. Okay, so the value inside the function will be what? 5, right? And then you have another print. Then look at this. We are not indenting anymore. We are outside the function definition, right? Oh, this is basically the function definition. Now, outside the function definition, again, I say a equal to 10 and I call the function now and I print something. Well, what is happening? A is 5, A is 10 here. So which A are we going to get printed in what order, right? Of course, when you go on to run this, the first thing, as soon as you define a function, I'll tell you how it works, right? So Python runs through all of these things. It will come here. It will say A equal to 10, but then it will go, the function is called, but then no parameters are put in because none of them are required. And eventually the executor, right, the interpreter will go here. It'll find out that A equal to 5, and as soon as it sees the print statement, it will print, hey, A equal to 5, and it's going to print a new line, and it's going to come out of this particular function. So as soon as it comes out of the particular function, now A equal to 10, right? So as soon as it sees the A equal to 10, of course, this particular scope of the variable A here is very, very, very different from scope of the variable A here, right? Because A equal to 5, and again we're calling A equal to 10. So you might be wondering about, hey, are we confusing anything? Absolutely not. The A here is confined to this particular function. The 10 here basically works throughout the entire program because it is not confined inside a function, right? That is one example I wanted to show you guys to talk about the lifetime as well. Now, we're going to talk about string functions in Python, right? There are so many strings. In fact, we just saw a string, right? The example where I showed you my name, Anirudh Rao, that's a string in itself. And everything that we've been printing right now, all the outputs are string outputs itself, right? So what we're going to do with respect to functions from now on is that when we're going to look at string functions, list functions, or any functions, basically we will not be bothered about what goes on in the backend to get the output for us. But eventually we will have to understand about what this function is doing, right? Of course, to sate your curiosity, you can also manually implement it to understand about how it eventually works as well. For example, I have a string here. Again, it's called Anirudh Rao, and I've just given a variable to it called name. And now what I'm going to do is I'm printing it here, but then I'm not printing the name. Don't get confused. Look at this thing. It says print len of name, right? So len of name is basically the length function where it will print the number of characters in my name. Now, if you're wondering, saying, hey, the number of characters in your name is actually 10, right? ANIRUDHRAO. Where is the 11th one? The 11th one is basically the white space. The space you see between Anirudh and Rao, that is also a string, right? Of course, that is considered. Then the next thing that we're going to do is understand that if we can go on to actually check if there's a keyword that is present in our string or not. Now, do you remember, like, every single time you want to search something, maybe on your page or something, you just hit Control F on Google Chrome and you start finding? Well, this is exactly that logic, but we have a function in Python to do us, right? I have a sample text. The sample text, sample underscore text has a string. It's called as welcome to great learning. And if I'm saying that, hey, if this substring, basically, if the word great learning is present in the sample text, print out a message saying the word is present, right? Now, as soon as I run this, of course the word is present, so it's going to say it is present here, right? But then if I change this to something such as ani, Ani isn't in the sample text. As soon as I go on to run this, I will not have an output here because I have nothing defined which says, hey, if the output doesn't exist, what do I do, right? So you can actually manually do it on your own. The word is not present, right? Now look, I'm actually coding this in front of you right now, and if I go on to run this right now, it says Ani is not present, but hey, let's go to Great Learning now again, right? Now, as soon as I go on to put Great Learning, here it will actually, it'll give you a print of what's there. Now, let me actually go on to remove this so that I can run this again for you guys. As soon as I go on to run this again, it definitely says the keyword is present in your text, right? So these are two very simple functions, right? The length function, and of course, we're taking a look at a function where we're trying to print a subtext as well. Now, an important thing that you guys really have to understand here is that these are not the only string functions out there, right? There's many string functions, and you will definitely be overwhelmed if you just take a look at understanding everything. So start simple, such as this, and work your way up there, right? Fantastic. The next thing that we're going to take a look at is the list function. Now, of course, list is a fantastic data type or data structure that you would work with when you're using Python, and I absolutely love working with it, right? Okay, so first of all, here we have a list. The list is basically vowels, and of course, it has all the vowels A, E, I, O, U in a jumbled order. Now, there is a fantastic function here, a list function called as the sort function. The sort function basically talks about how you can sort something either in the ascending order or in the descending order, right? Now, as soon as I go on to print this, basically it just arranged everything. The sort function basically arranged everything for us in the ascending order. But what if I want it to be arranged in the descending order, right? So this is where I have a parameter called as reverse, and all I can type is reverse equal to true. And that's about it. Now it's going now that everything just goes back to being the descending order, right? Instead of A, E, I, O, U, you now have U, O, I, E, A. How's that, right? Fantastic. You're sorting it either way, but then depending on what it is that you want to use to sort, you can go on to use that. Fantastic. Take a look at the next list here. We're going to be adding an element to this list. This list is basically the flowers list. I have three types of flowers here: roses, lilies, and jasmines, of course. There's a function here. What you have to look at is called as the append function. Append in its English meaning basically means to attach to something, to add on to something that already exists, right? So flowers already exist. This is a list that already exists, and I'm attaching one more element to it, and I'm printing it. Pretty simple, right? But can you append something to a list that doesn't exist? Well, you think about it. If there's nothing and you want to start adding on to it, there can be two options, right? One option is that it's a brand new list which has no element, so you can actually start appending directly. Or the second train of thought will say that, hey, no, this is a list is not at all present. How can you go on to, add something to something that doesn't exist, right? Now, I want all of you all to head to the comment section and give me an answer to what will happen if you just randomly append something without having the flowers there. Of course, if you don't define the list, you're going to have an error. If you define an empty list and try to append, that is what I want to find out from you guys. Okay, cool. Now that we're done with list functions, the next thing that we're going to take a look at is something called as the nested functions. One fun thing you guys really need to know about functions here is that with respect to functions, right, you can actually have one function inside another function. That is where you say nested. You might have heard of this concept when you were learning the concept of loops, right? Nested loops. You'll have multiple for loops, one inside the other. You can have a while inside of a for inside of a while, a for inside of a for, a while inside of a while. You can have any permutation combination that you want to use to get to your eventual logic, right? So here we have one function. The first function we're going to have is called as the outer function, because it basically talks about everything, right? The scope of this function is until here. So this outer function just takes care of the entire two functions for us. Of course, the first function has a print message where it says this is the outer function, and then we have defined another function there. We're calling it the inner function. Now this inner function is also printing something for us. It says this is the inner function, right? And of course, whenever you guys go on to define a function, don't leave it at that. Make sure you call the function to check its functionality. And remember, this inner function is also a part of the outer function, because if this wasn't the case, if you were to not indent it and put it outside, this particular thing would not execute, right? Whatever the piece of code I have selected, it will not run if your inner function call is outside. But now that it's inside, as soon as I go on to print this, how this will work is, Python will come here. As soon as it sees a function call, it's going to run the function. Then it already knows that the function is defined. So it's going to go on, print the first line, says this is the outer function. It sees the definition of the inner function, but it will just process it and keep it ready until there is a function call. But then as soon as it does that, there is a function call for the inner function as well. So it's like, hey, print this guy as well, right? So this is a fantastic, simple example for you guys to understand the functionality of nested functions. And also, guys, do not get confused with one important thing. Whenever you guys are talking about nested functions, they have another name as well. It's called as inner function, right? One inside the other, inner function. So when you're asked a question saying what are inner functions or what are nested functions, understand that the answer is one and the same, right? Fantastic. Now, here is another important function. It's called as the Lambda function. The Lambda function in Python is a very popular choice for the interviewers to quiz you as well. And it's a fantastic function if you know how to go about using it. It will just reduce your code even further where you're having a custom function as well, right? Now, what do I mean by that is, let me actually explain what I mean here, right? Triple. I have a variable here called as triple, and then I have some another keyword here called as lambda, and the lambda function says x such that x into 3. Well, what does that mean? Well, basically, when I say, hey, what is the lambda function? This is the lambda function, and how you read it is, hey, x such that x multiplied by the value of 3, right? Now, what I mean by that is, if you pass any value x to the function here, to the lambda function, it will give you an output which is multiplied by 3. If I give it 1, it's going to give me 3. If I input x as 2, it's going to give me what? 2 into 3 is what? 6, right? Now, what I'm going to do is I'm going to call this particular function inside another print function inside a function. Get it? Fantastic. Now I'm going to call this lambda function inside this. I'm going to be passing the value 5 to it, right? Now as soon as I pass the value 5 to it, what do you think is the output? What is 5? 5 such that 5 multiplied by 3. What is 5 multiplied by 3? It's 15, right? Simple. Now here is how you would do it if this was a normal function, right? If you didn't have a lambda function, you have to go on to manually put x equal to 3. You have to define a triple function. You have to call a return specifier. You have to put the logic in the return specifier there, and then call the function, pass the value. Look at this. All these difficult pieces of 1, 2, 3, 4 lines of code, which can be very confusing, is actually brought down to 2 very simple lines. And this piece of code is reusable everywhere, right? Of course, this is also reusable considering it's a function. But then we're talking about 2, 3 lines here. Imagine it in the scale of 200 or 300, right? That is when definitely you guys would want to, try to see wherever it is possible to shorten your code and simplify your job, right? Again, the triple function here, x is equal to 3. So 3 into 3 is 9. Let's just put x equal to 5 to just see if it works. Of course, 5 into 3, 15 should work. This is how you would do it in a regular way, and this is how you would do it in the lambda function methodology, right? Okay, cool. Now that we're done with the lambda function, the next thing we're going to take a look at is the math function. Now, as I told at the start of this particular demo itself, right, all of these functions we're talking about, it is not just 2 or 3 things, right? I've kept it to a very simple degree to make sure all of you all understand, but understand that there is many other functions as well. So I want all of you all to head to the comment section and tell me which other functions in which of these categories, list, string, math, Boolean, wherever it is or whatever it is that we're discussing, what it is that you did, right? Any interesting functionality that you could come up with, I definitely want to know about it. So make sure you guys head to the comment section, right? Fantastic. Now, alright guys, the first thing that we're going to do is find out how we can go on to manually understand the square root of a number, right? Of course, if you have a number and you divide that number in a way where it multiplies 2 times of the same number, that is when you would call it a square. But then when you're doing it in the opposite order, that's when you would call it as a square root. For example, what is 3 squared, right? 3 squared, the logic is 3 into 3. The answer is 9. So what is the square root of 9? The answer is 3. I am sure you guys know this, right? Superb. Now there is a function in Python that will help you do this instead of actually manually doing this. Now as a fun experiment, however, it's a very simple thing to implement manually as well. If you remember long division and if you understand of how you can implement division in Python effectively, you can actually get to this very quick, right? So let's see who gets it in the comment section, right? So for now, we're going to be discussing the square root function where any parameter I pass into it, the output will basically be the square root of it. For example, if I run this right now, the answer should be okay, it's giving me 5 because this is the last thing that it executes, right? Now what I'm going to do is I'm going to comment this one particular keyword here, and now as soon as I run this, again the answer should be 3.0. Why? Because square root of 9 is 3, right? What is the square root of 25? The square root of 25 is 5, right? It's a pretty simple function to work with. And then we're going to have another important function. This is the exponentiation function. Exponentiation again is exactly the opposite to square root, but it doesn't have to be all the time. For example, 2 power 2 is what? 2 into 2, right? 2 power 3 is what? 2 into 2 into 2. And if I ask you, hey guys, what is 3 powered 5 or 3 raised 5, right? What that basically means is 3 into 3 into 3 into 3 into 3, 5 times, right? So that is the top number indicates how many times the same number has to be multiplied. I am sure you guys know all this already, right? But here is the syntax which you might not know. We have a function called as POV. Basically, it's power. It stands for power, POV, right? So here what we're trying to do is actually trying to raise 2 to its power of 3. So when I say what is 2 raised to 3, right? That is the syntax that you can use. The number at the base is going to be on the left side, then you'll have a comma, and the exponentiation will go on the right. Now, as soon as I run this, what is 2 power 3, right? It's 8. Simple. We already have that particular answer. Next is what is 6 raised to? What is 6 are? 36, right? Done. As simple as that. Again, you have multiple functions. With respect to math functions, I highly suggest you guys check out the entire list that is available. Of course, you can find the list in multiple places online, and I would highly suggest you take a look at that because math functions are really common and you will be using it a lot of times, right? Okay, cool. We're down to our last 3 types of functions: recursion functions, pure functions, and Boolean functions. Let's get started with recursion function, right? Recursion basically talks about how you can continuously be looping inside the function to have a logic where things work. For example, think about factorial, right? I am very sure you guys know how to implement factorial, right? If I say what is 5 factorial, it is 1 into 2 into 3 into 4 into 5. Similarly, if I say what is 10 factorial, it is everything multiplied from 1 to 10, right? 1 into 2 into 3 into 4 into so on until 10. That is a factorial, correct? If you have to manually implement this is the logic. We're going to be defining a function here. The function is called as factorial, of course. We're going to be passing it a value because we need to give it an input. Factorial of what, right? Factorial of a. In this particular case, if a is equal to 1, return 1. Why is that the case? Well, you have to manually implement this logic because what is 1 factorial? It's 1 itself, right? So you have to manually implement this, or else when someone types 1 in the if you have the same logic, it will not know what to understand. It's going to implement this logic for you guys. 1 into 0, 0. It's going to say 1 factorial is 0, right? If it is anything apart from 1, then it will multiply itself where it is calling the same function again. This time it is sending the value a minus 1, right? Now if I had the value 5 here, the first time it runs through this factorial of 5, it's going to skip this because 5 is not equal to 1. It's going to come here. It's going to be like 5 into factorial of a minus 1. What is factorial of a minus 1? It's 4, right? So it's going to multiply 5 with 4. It's going to do it again. 5 into 4 into 3. It's going to do it again. 5 into 4 into 3 into 2. It's going to do it again. 5 into 4 into 3 into 2 into 1. But when it comes to 1, it will just return 1 and say, hey, we're done, right? So here we're inputting the number 5 and we're basically calling the function here. The input of 5 is basically to give you a better understanding of the output message we have just printed, and eventually this is where we are calling the function, right? Factorial of the input number. Now as soon as I run this, it will say factorial of 5 is 120. Why? 5 into 4 into 3 into 2 into 1 is 150, right? Similarly, what is the factorial of 10? It's going to be a very large number, right? Let's take a look at it. The factorial of 10 is 36,28,800. Fantastic. This is you doing it manually. But look at all of these lines of code, right? This looks so complex to implement for a beginner. But if I were to ask you saying, just find the quickest way of just give me the factorial rather than all of these things, this is what happens. In the back end, this is exactly what is happening that Python is doing for you. But in the front end, to use all of its functionality, all you have to do is use the math function. Factorial of 5 is 120. What is the factorial of 10? We're going to see that big number again, right? So I print it, it says 36,28,000. Would you do 1 line or would you do 10 lines? It's your call, right? Simple. This is the reason why we have functions out here. Now that we're clear with recursive functions, let's go on to take a look at pure functions. To understand pure functions, you guys really need to understand what an impure function is. See, with respect to pure functions, what happens? Why is this not a pure function? Now, let's just run through what the function is doing. We have one more function called as crop underscore function where you're passing the value z, and we're trying to delete the first element of that particular list list and we are trying to return the list for us, right? Fantastic. We understood this function. What's the next one? The next function is basically us printing out something. But here is where we have the list 1, 2, 3. And now I'm going to be calling the crop func. I'm going to be calling the crop function where I want to remove the first element there. I'm going to be printing B. I'm going to be printing A. As soon as I go on to run this, you will see 2, 3, 2, 3. Why is that? First of all, as soon as you go on to call the printval function, it's going to come here, it's going to understand that A is a list of 1, 2, 3. But then even before we printed, B is called, right? As soon as B is called, it knows that whatever comes in the first element, just delete that, right? As soon as it goes there, 1 just goes, 1 is deleted. You can actually delete another element too. For example, if you want to delete the first element, just use another index position, right? Z of 0 talks about the first index position, I'm sorry. Z of 1 talks about the second one. Z of 2 talks about the third one, right? Python is a language that is indexed from 0. Now, this is not a pure function. Here, I have a pure function for you guys where we have a crop func and I'm returning Z of 1 is to everything from the first one to the end. This, you see, I am just filtering it. I am not making any change to the original list that I will have. Now, after this entire piece of code is run, what do you think is going to be B, right? B is going to be another list where you have the entire thing cropped. Everything that this function sees, the list that this function sees is going to get changed because there is an element that is being deleted. So, in the pure function, what are we doing? We're not doing any of that. All we're trying to do is we're going to have the same functionality, but here, all we're trying to do is go on to print it, right? Let's just scroll quickly back to the not a pure function again to understand this one more time, right? First of all, what are we doing? Why is this not a pure function? This is not a pure function because in this particular part, in this particular logic, we are trying to make a change. We're trying to make a change to the original list that we have, or the original list that is considered in the scope of this particular variable, right? So when you go on to make changes, you're actually changing the thing, the initial element, the initial variable, the list, the tuple. Of course, you cannot change a tuple. Oh, that was a trick question, right? Of course, but then if it's a set, it's a dictionary, the same logic, right? Once you have it set something initially, and eventually later you keep changing that and you work with it, it is messing around with the original value, right? That is what makes it not a pure function. And of course, with the pure function, we're not trying to delete anything. We're just trying to filter it by making use of substring operations, right? As soon as you go on to print this, it still is going to give me an answer, but this time you will see that, hey, our original list is still 1, 2, 3, but whatever we have cropped, that is working fine as well, right? Functionality is there. The original list is not changed. The efficiency is really good and it works really well. And of course, you should not go about changing the original thing unless you have a backup of it or unless you know what it is that you're messing up, especially if it's something, if it's an application which is complex. This is where pure functions come into the picture, right? Fantastic. I hope we are clear with pure functions. All right, guys, coming to the last type of function we're going to be working is the Boolean function. Now, working with Boolean function, before we get into the function part of it, there's a function called as the bool function, right? Instead of getting into that, let's take a look at Boolean evaluation. Whatever you see in the bracket of the print, consider that to be a question that I'm asking you guys, right? Is 15 greater than 10? Of course, 15 is greater than 10, right? It's common sense. Now, if I ask you the same question, is 15 equal to 10? Well, 15 is not equal to 10. Is 15 less than 10? Hell no, 15 is not less than 10, right? So if I ask you these questions, you will say yes, no, no. Or you will say true, false, false. What is Python going to tell us? It's going to tell us the same thing. True, false, and false. Boolean talks about true, false, 1, 0, yes, no, right? Fantastic. This is evaluation part of it, implementing a Boolean evaluation. Now, the last thing that we're going to take a look at is how you guys will be using the bool function here. First of all, I have a couple of variables, A, B, C, and a sample list. A is basically storing the string. It's called hello. B has a value 15. C, interestingly, is initialized to 0. And we have a sample list, which is empty, right? There is nothing inside the list. Now, what do you think is going to be the output when I print Boolean of A, Boolean of B, Boolean of C, and a Boolean of the empty list as well, right? Well, fun fact, it's going to be true, true, false, false. Why is that the case? Basically, you have to understand this about the bool function. If your final output, when you ask the question, if the answer is none, if the answer is 0, if the answer is false, or if the answer contains an empty data element, for all of these 4 cases, your answer is going to be false always. Apart from these four cases, you can provide anything to your input and run a bool function on it. It's going to be valid, right? Now, this is false. To make this true, all I have to do is add something to it. If this is not 0, it's going to be true, right? Look at that. It's going to say true, 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 false. But if it is 0, if it is none, if it is null or anything of that sort, it's going to say false, right? This is how those four cases that I just told you, remember those four cases and you're done with Boolean functions. Apart from those four cases, everything is true unless it comes to those four cases. When it comes to those four cases, everything is false, right? If it's 0, if it's none, if we're trying to use an empty list, and of course if it's a Boolean false to begin with in itself, right? Superb, guys. This was the demo that I had planned for you guys so that you can have a quick overview and in fact an understanding of not only how you use functions or how functions are used and worked with in Python, but the goal here was to showcase how simple your life will be if you use functions, right? Now, these are really simple examples. Now implement the same logic when you're working on a very complex problem in your favorite domains, maybe web development in Python, maybe data science in Python, right? So whenever you want to work on those domains, that is when eventually this will help you a lot, right? So once you get to a point where you're working on it intermediately and you're using functions and you realize that, hey, I learned this from Great Learning from Anirudh Rao, and now that I understand that this works really well, then you'll be like, okay, yes, superb, right? So fantastic, guys. So that was a joke. I was just messing with all of you all, okay? Superb. So we can actually have this entire notebook shared with you all, but then I want all of you all to actually go on to do it manually, even though we will share the notebook as well, right? So guys, manually try to implement a couple of functions. If you have any doubts in understanding any of these functions, head to the comment section and put a message down. I'll be more than happy to help you out there, right? Okay. Alright, guys, so to summarize everything that we have learned on this particular video, we started out this video by understanding what are functions, how they are used, where they are used, why they are required, right? Once we understood that part of it, we also took a look at understanding how we can create a function of our own, and also understanding everything about not only defining a function but also calling a function. Once we understood this, we took a look at multiple examples where we defined a lot of functions, and we also understood how the built-in functions also work, right? And then of course we took a look at the various types of functions that are out there, built-in functions, and we have the user-defined functions, and we created a lot of functions, right? So to summarize everything up, we took a lot of understanding in terms of list functions, in terms of recursive functions, pure functions, math functions. We took a look at the fantastic concept of recursion and a lot more as well, right? So I hope you guys are clear with everything that we've discussed on this particular video. Again, if you have any comments or if you're finding trouble implementing any function, head to the comment section and do let me know. I will help you out. Alright, on that note, thank you guys. You've reached the end of this particular video. My name is Anirudh Rao and I'll see you on the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains, absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.